Hello, Internet. My name's Daniel Nausner. I'm on Seattle University Electrical Engineering ECE 14.4 Senior Project Team, and we got some really cool stuff to show you. And first thing I'm going to do is introduce you to our team. Okay, let's go meet the team. Hey.
I'm Andrew Newborn, and I'm part of Los Chupacabras. We were previously the Dream Team, but now we're Los Chupacabras, aka Team 14.4. So today I'm going to be telling you about what we are working on. We are working on designing a microgrid for Christie's Cape Academy in Mahuru Bay, Kenya. A little background on Kenya. 1 in 4 people there actually have a lack of access to electricity, which is a huge amount. And without electricity, there's a lot of problems. Kids aren't able to study at night. Kids aren't able to read at night. Household chores cannot be done at night. So by installing this microgrid, we're going to be able to help alleviate poverty and hopefully help the community sustain itself. At this Christie's Cape Academy, there are 300 students, and the grid will be connected to the school. But we will also be providing PBKs, aka portable battery kits, to the entire community of 900 people in order for them to have electricity in the households. Now I'm going to pass it over to my boy Pat.
Hey, Pat.
Hey, I'm Patrick Berg, and well, here we have a diagram of the system we will be designing. Over here on the right, we have the wind turbines, and we have the photovoltaics, which are solar panels, and that they will gather wind from the environment through either sun or wind, and they will go through the control. They'll go through the converter, and it will be stored in the station batteries. And as energy is drawn from either the school for portable battery kits or other loads, they will pull from the station battery. And more on that, we'll send you over to Mike.
All right.
On Homer.
So, Mike, you're working with Homer. What's Homer?
Homer is a modeling software that we needed to have so that we can put all the information that Patrick is drawing up on the board into this modeling software so that we can enter the data for the wind resources that we gathered from a company that we imported the file from, or we can get the sun data and we can put the latitude and longitude of Mahuru Bay and the time zone and gather pretty accurate sun data from the area. And then we can put it into this model as our load or our converter. Pretty much the same thing Patrick had on the board we can make in this software. And when we put it in the software, it's going to calculate all these different scenarios, and so that we can come up with our initial cost and we can choose the best fit of the system. And when it comes out, it'll give us our cash flow summaries, our electrical outputs, our PVs, and our outputs from our air turbines, and our stationary batteries, and we'll know if there's a drain on the system.
Yeah, and it'll give us lots of questions to ask the people in Kenya, right, about how this is going to work, huh?
Yes.
Good. So that's great. Thanks for sharing, Mike.
Yep, no problem.
And that's about all we have time for today, but hey, stay tuned. We're working on a lot, and it's going to get really interesting. So thanks for paying attention.